Formula for calculating work done and power is still the same. Says energy must be available for work to be done. And energy is the ability or capacity to do work. We all know that. And when force is applied, it's an indication that energy has been transferred and work has been done. Okay, so with the work done, it's still the same formula in physics, which is force multiplied by the distance or displacement of the point of application of the force. So work done is force times distance. Work done is force times distance. And the rate at which work is done is power. So we talk about rate, we talk about time. So the rate at which work is done is power. So which simply means that power is work done over time. And then if you say power is work done over time, work done is force times distance. As you can see, distance over time is velocity. So you can easily say that your power is equals to the applied force multiplied by what? Velocity. Sometimes you might be asked to calculate power, but then you have your work done. So you just, and your time. So you just divide by time. Sometimes you will have to use this formula to calculate power. I think that is just what is here in this section here. It's nothing much. Okay, so with the knowledge of that, I'm not sure if you guys can try this activity. Let's look at this activity together. I'll also be asking some questions as well. This is just 5 marks. They said an object with a mass. Um, First thing I want to see is your data, guys. I'm not a strict marker. Don't be scared. The mass of the object is 5 kilogram and is lifted upward for 8 meters. What I just need there is just the data. Which one is distance? Which one is mass? 8 what? Meters. Then it has a uniform velocity for 6 seconds. Don't know if you guys can try this. The first question there says that you must calculate the work done. Work done is what? Work done, we know that work done is force times distance. So the force in consideration here is the weight. Is weight multiplied by distance s. Weight is what? Mass times gravity multiplied by distance. The mass is what? 5. This 5 times 9.81. The distance there is what? It's 8 meters. So here you get your work done. Linda, you must prepare yourself. You're giving me the answers. The power, of course, because you have your work done, power is the rate at which work is done. So when you get your work done here, so you just divide by time in order for you to get your power. What's the work done? 392.4, right? What's the unit for work done? Joules. So this one is going to be what? 392.4 divided by what? The time is 6 seconds. So this will give you what? 65.4 what? What's unit for power? Watt. Don't forget to put the unit there. There is a half mark for the unit. These ones are easy ones. Let's look at question 2. Let's look at question 2 together. A rolling object with a mass. I hope you guys are not still writing this online. So this is a typical exam question. It said uh, a rolling object with a mass of 30 kilograms. Let's look at this. Let's see what's happening there. The mass is what? 30 kilograms. At rest on an horizontal plane. A horizontal force of 80 newtons is applied to displace the object horizontally. So it simply means that that force was applied to pull the object horizontally to move a distance of 120 meters. So the rolling resistance, of course, just as we have for frictional resistance against motion, is 30 newtons. We are to calculate the work done against frictional force. Now we know that work done is force times distance. Now, because we are to calculate the work done against frictional force, we're going to define this force now. So it's going to be the resistance force multiplied by distance. The work done against the frictional force or the rolling resistance that is opposing that motion will be equals to that force multiplied by the distance. So that force is what? Is 30 newtons. It's going to be 30 multiplied by what? 120. That will give us what? 3,600 what? Joules. You can convert to kilojoules if you want. 3.6 kilojoules is still correct. The total work done, we know that work done is force times distance. So in order for you to determine the total work done, so the total work done here is going to be equals to the horizontal force that is applied, which is 80 multiplied by the distance, which is 120. 9,600 what? Joules. I'm still going to give you work here. The C part, the work that is transformed into kinetic energy. Yes, then you have this way you subtract 80 from 30. The work done is force times distance. So the force is going to be the effective force. So the force that has been transformed into kinetic energy is when you subtract this horizontal force minus this resistance force, that you multiply it by what? By distance. Yes, I think you are right there. I've seen that. Work that is transformed into kinetic energy. So we know that work done is force times distance. So that is going to be the effective force. So it's going to be 80 more than 20, right? So the work that is transformed into kinetic energy, 6,000 joules. Okay, I want you guys to try the last one. The total power when the force is applied for 15 seconds. Work done over time, right? So with total power, we are going to use total work done. So our total work done is what? 5,600. What's our time? 15. So that gives us what? 640. 640 watts. Let's continue. We are building capacity here. So that is what we are actually doing. Solving fresh questions from the foundation so that we'll be able to gain understanding of what we are doing. This is actually how you learn. You learn by doing. Question 3. Can you guys try question 3? And I want you to look out for all these keywords. Constant velocity. At constant velocity, there is no acceleration. Acceleration is zero. But in this case, now we're going to determine the distance and the force in order for us to calculate the work done. So I'm going to solve the first one. I'll wait. Then after then I'll solve the B part. The work done after 10 seconds. Let's see. Work done is force multiplied by what? Distance. That is the pulling force. So we need to calculate force and distance. So we are going to use that equation. These two are facing down there. They have to be greater than that for that to come down. Plus W sine theta minus what? 300 equals to what? Mass times acceleration. So this one is going to be equals to 0 because it's at constant velocity. So we are going to have this as F plus. I'm just going to do this 120 times 9.81 sine 12 degrees equals to what? 300. So we are now going to, this is going to be 300 minus 120 times 9.81 sine what? Sine 12 degrees. So we're going to get our force there. 55 comma what? 225. So let's determine our distance. Distance is what? Velocity times time. Velocity is 3, time is what? 10. So distance is what? 30 meters. So we can now revert back to this equation here. Work done, force times distance. So it's going to be 55.25 multiplied by 30, 1657.5. Can you try this one? 3B, the power required for 10 seconds. Need another space here. You just divide that work done by 10. Because power is work done over time. What you got here, so the work done, you got 1657 point what? 5 over 10. 165.7